Okay. Sorry, just making sure this fits to Windows so people can see a bit better. There we go, that's better. Right, yes. Game development. Strangely nervous about this. Anyway, first things first. Good morning, good afternoon, or good evening, time zone depending. I am, of course, King Crix Britannius, and I welcome you to the court. Now, as I mentioned on Twitter and in my debut video, if you've had a chance to watch it, but if not, no worries, I'll recap. One of the things I've wanted to do for a long time, and partly why I went to university, is to become involved in the game development scene, either as, well, certainly not as a graphical artist, because I'm not particularly talented at that. I have no artistic bones in my body, I'd think. But some capacity I wanted to work in game development, either as a tester or similar. And I thought, whatever. A good way to do it is to get in to start would be as a developer, so coding and programming and so forth. And that's what I went to university for. Although I didn't join a game development course. I did a software engineering course, which is basically programming. So using things like C++, Visual Basic, which is less suited for. Which was not really suited for game development at all. Truth be told, it's more of an application programming language. But that didn't stop me trying anyway. And it's through the years, nearly 20 since I graduated from university. I've always had the idea of I want to be doing something. I want to be creating something in it, some kind of video game. Because I'm sure many people out in the world have many ideas for games they want to create, but no real way to realize them, shall we say. And I just figured, I started as a voice actor some 3 years and almost 6 months, 3.5 years at this point. Which is all well and good. However, work is what it is. You can't really dictate when work will be coming, when you'll book a role or anything in voice acting. So I figured I still want to be doing something, and I started VTubing very recently, the past couple of weeks, and I figured, why not combine the two? Why not combine VTubing and my desire to create a game, and we'll do it all at the same time. And hopefully that'll be interesting. Hopefully maybe people even follow along and create their own stuff at the same time, which would be nice. But we all have to start somewhere. We all have to learn, and I'm effectively going to be relearning programming from scratch, because it's, like I say, it's been nearly 20 years since I last did any programming, like proper programming. I have done SQL coding in work for queries and stuff, but it's nowhere near the same. Nowhere near the same. So, what I'm going to be doing is I'm going to be using following a tutorial book called Godot for Game Development Projects, written by Chris Bradfield, and just going through it slowly, step by step, just to try and understand, and we'll try and understand at the same time what's going on, why it's happening, and hopefully by the end of it we'll have a working game, and I'll be that much closer to realising the kind of games I want to. Hopefully. But let us continue. So, what I've done is, what I've got open at the moment is the Godot engine, or Godot engine if you're like me and you're never quite sure how it's pronounced. It is, I think it's freely available on Steam, which is where I've got it, but you can download it directly from Godot's own site, and I'll tweet a link to them after. Sorry, let me make a reminder for myself to do that. Yes, I still use pen and paper because I am just that old. Retweet link to Godot after stream. Cool. So that's that. And we'll also try and raid into someone after the stream as well, because I know I was aware it didn't quite go as planned last week, because the scuff was real. Very real last week. Apologies for that again. But anyway, we begin. So, opened a new project, which is what we've got on screen. Nice and empty, completely blank slate. We are going to be following the first tutorial, which is a coin, well, it's called Coin Dash. And there are some assets available, which you can download, and the link is available in the book. So if you want to follow along, get yourself the book, get the assets. They're free to download because it's hosted on GitHub. And off we go. So, I'm going to move the mic a little bit. Apologies for any horrific noises you're about to hear. It's just vibration of the mic arm. Do that. Probably should have done this at the start before I went live, but screw it. We embrace the scuff around here. We embrace it. So, let's see. Turn my light on. Don't want to get eye strain. Now then, in this project you'll make 3 independent scenes. The player character, the coin, and a display to show the score and clock, all of which will be combined into the game's main scene. See Chapter 1. So, to explain what a scene is in Godot, everything that comprises the visuals of a game is called a scene. And you combine multiple scenes together into one main scene, which is the visual that the players will see on screen at any one time. Scene, screen, that's going to be a tongue twister. I'm going to trip over that, I can tell. Now, for ease of, well, for housekeeping, general housekeeping, it's recommended that you partition all your assets into separate folders, because one, if you need to refer to them at a later date, or you need to reuse them or edit them in some way, shape or form, it's easier to find where they are rather than trying to root around in one large collective folder. But that's if you're making a big game. For a smaller game like this with Coin Dash, which is quite a small project, you can get away with putting it all in just one folder because it's not going to comprise very much at all. But here we go. Why am I stalling? Because I'm really, really nervous. I don't know why. Let's see. Where we got to? Yes. In a larger project, it might be useful to create separate folders to organize each scene's root folder, which I was just talking about, which is referred to as a res / res is short for resources, obviously. All resources in your project will be located relative to the res folder. You can see the project's files in the file system dock in the lower left corner. Because it's a new project, it will be empty apart from a file called icon.svg, which is the Godot icon. So this little chappy here. Since this game will be in portrait mode, taller than it is wide, we'll start by setting up the game window. I hope everyone's enjoying the music as well. I'll try to create something that was a bit more upbeat. I need a better organised desk. I don't have enough space. This is a corner desk, but there's no space for anything. It's really frustrating. I need a book stand. That's what I need, a little book stand. Will this work here if I balance it? Will this work? It might. Are we science? Come on, science with me. Good enough. Right, here we go. Right, click project settings from the menu at the top. Project settings, here we go. Look for the display windows section. Here we go, and set viewpoint width to 480 and viewport height to 720. Borderline mobile display, that. Also in this section, under stretch, set mode to canvas. That's not it. Ah, here we go. Canvas items. And aspect to keep. Well, that's already set, so that's fine. This will ensure that if a user resizes the game window, everything will scale appropriately and not become stretched or deformed. That's good. You can also uncheck the resizable box under size to prevent the window from being resized at all. No, we'll leave it. We'll leave it resizable. Congratulations, you've set up your new project. Hooray! This is our base point. You're ready to start making your first game. In this game, you'll make objects that move around in 2D space, so it's important to understand how objects are positioned and moved using 2D coordinates. In the next section, you'll learn how this works and how to apply it to your game. So we're going to be embarking on some quite significant education. Anyway, vectors and 2D coordinate systems. So a bit like if you're used to reading maps, this might be fairly simple for you. This section is a very brief overview of 2D coordinate systems and vector math as it's used in game development. Vector math is an essential tool in game development, so if you need a broader understanding of the topic, see Khan Academy's Linear Algebra series. And there's a link to Khan Algebra. Which is www.khanacademy.org/math/linear algebra, and I will probably need to take that course offline because I'm not the best at maths, especially algebra. So this is going to be interesting, but we progress. When working in 2D, you'll use Cartesian coordinates to identify locations in the 2D plane. A particular position in 2D space is written as a pair of values such as 4, 3, representing the position along the x and y axes respectively. Any position in the 2D plane can be described in this way. In 2D space, Godot follows the common computer graphics practice of orienting the x-axis to the right and the y-axis downwards, so opposite to standard graphs, I suppose. There's a little box out here saying, "That's not what my maths teacher taught me," which is just what I'm alluding to, actually. If you're new to computer graphics or game development, it might seem odd that the positive y-axis points downwards instead of upwards, which you likely learned in math class. However, this orientation is very common in computer graphics applications. Alright, no explanation why. Fine. Vectors. You can also think of the 4, 3 position as an offset from the 0-0 point, or origin. Imagine an arrow pointing from the origin to the point. Really wish I hadn't thrown away my book stand. That would have been really useful right now. The arrow is a vector. It represents a great deal of useful information, including the point's location, its distance or length in m, and its angle from the x-axis, 0. More specifically, this type of vector is referred to as a position vector. That is one that describes a position in space. Vectors can also represent movement, acceleration, or any other quantity that has a size and a direction. In Godot, vectors have a wide array of uses, and you'll use them in every project in this book. So there's 5 projects in this book, so we're going to be doing a lot of maths. What fun. You should now have an understanding of how the 2D coordinate space works and how vectors can help in position and move objects. In the next section, you'll create the player object and use this knowledge to control its movement. Part 1. The player scene. Just as Firestone kicks in. Nice. The first scene you'll make is the player scene. One of the benefits of creating a separate scene for the player and other objects is that you can test it independently even before you've created other parts of a game. This separation of game objects will become more and more helpful as your projects grow in size and complexity. Keeping individual game objects separate from each other makes them easier to troubleshoot, modify, and even replace entirely without affecting other parts of the game. It also means your player can be reusable. You can drop this player scene into an entirely different game and it will work just the same. Now this is very, very crucial because in a future project, one of my first ones I want to make, once I've got my programming skills up to snuff, is a platformer. And being able to, well, as the book just said, diagnose and bug fix issues with the player character will be kind of critical. And there are existing templates for 2D platformers. They're very basic templates, but they'll provide the foundation from which we can build up from. Which means that we can create there'll be like a shell player character and a world, and then through further development and refining and design, stumbling for words here, we can expand that into the world I've got in my mind, and then replace it with the assets that I want to use. That I want to use and possibly even create, and I do have a sprite creation program also installed that I also got through Steam. Funny enough, it's very cheap actually. It's called Asprite or Asprite. I forget. Either way, but we'll be able to create the assets in Asprite and then import them to Godot, hopefully. And then we can use them as we see fit. It's going to be brilliant. In theory, it's going to take a long time because I'm slow, and not an artist in any shape or form. So creating the actual character art is going to be an exceedingly difficult challenge. But we'll try our best. And if, worst comes to the worst, we can look for some kind of graphical artist to work with going forwards, and that's something I'd like to do in the future as well. I think if things really take off, and I'm in a position where I either need to work with people or have a means of employing people and paying them fair wage, then I'd look to create a studio to then start realizing more of the ideas, and have people who are more competent programmers. We'd have artists, we have audio engineers. I already have someone who can provide music because I know a composer. I've worked with her quite a few times. She's very good, and she wants to get into the video game space for composing work. So I'm thinking this would be a nice opportunity for her as well. Suffice to say, this is going to open a lot of doors, hopefully. That was a long tangent from setting up a player scene. But no one is here for coherent, concise, cohesive thoughts, I'm sure. I'm a VTuber after all. Now then. Your player scene needs to do the following things. Display your character and its animations. Respond to user input by moving the character. Detect collisions with other game objects such as coins or obstacles. Creating the scene. Start by clicking the Add/Create a New Node button. The keyboard shortcut is Control-A and selecting an Area 2D. There we go. Where's me Area 2D? I've got Node 2D. There we go. Oops. Click on the node's name and change it to player. Apologies, I keep whacking the microphone cable. Get out of the way, cable. Move. Shoo. Be gone. Out of my way, or I shall cast testicular torsion on you. Bastard. Anyway, there we go. Done. Click scene, save scene to save the scene, of course. Save scene as player. Yes, that's fine. Cool. Nice. Take a look at the file system tab and note that the player... Let's move this over here, I can see a bit better. Not twist myself up. Take a look at the file system tab and note that the player.tscn file now appears. Whenever you save a scene in Godot, it will use the .tscn extension. This is the file format for Godot scenes. The T in the name stands for text because these are text files. Feel free to take a look at it in an external text editor if you're curious. I've done audiobooks, this shouldn't be a challenge. But you shouldn't edit one by hand, otherwise you run the risk of accidentally corrupting the file. Fairly important. You've now created the scene's root or top level node. This node defines the overall functionality of the object. We've chosen Area 2D because it's a 2D node, so it can move in 2D space, and it can detect overlap with other nodes. So you'll be able to detect the coins and other game objects. Choosing which node to use for a particular game object is your first important decision when designing your game objects. Before adding any child nodes, it's a good idea to make sure you don't actually move or resize them by clicking on them. Select the player node to hover your mouse on the I'll try that again. Select the player node and hover your mouse on the icon next to the log. Group selected nodes. No, that's not it. Do that later. Oh, it's at the top. I'm missing a toolbar. Where's me? Ah, there we go. It's on the wrong tab. Durr. Lock selected nodes. There we go. No, I want group. Where is it? Group, group, group. Ah, there we go. Right. The tooltip says make selected nodes. Got an extra window. Get out of it. The tooltip says make selected nodes children, not selectable, and that's good. It'll help avoid mistakes. Click the button and you'll see the same icon appear next to the player node's name. Yes, good. It's a good idea to always do this when creating a new scene. If an object's child nodes become offset or scaled, it can cause unexpected errors and be difficult to troubleshoot. Sprite animation. With Area 2D, you could detect when other objects overlap or run into a player, but Area 2D doesn't have an appearance on its own. You'll also need a node that can display an image. Since the character has animations, select the player node and add an animated sprite 2D node. There we go. Create. This node will handle the appearance and animations for the player. Note that there's a warning symbol next to the node. There's one next to the player node as well, in fact. Animated Sprite 2D requires a Sprite's Frames resource, which contains the animations it can display. To create one, find the Frames property in the Inspector window and click on Empty to see the drop-down. Frames property. Scream if you see it. Find the frames. Ah, inspector window. Duh, read properly. Animation, frames, here we go. And click on empty to see the drop down. Select new sprite frames. Yes. Next, in the same location, click the sprite frames label that appeared there to open a new panel at the bottom of the screen. Sprite frames. Ah, there we go. On the left is the list of animations. Click the default one and rename it Run. Then add the Add Animation button. Named Idle and a third named Hurt. So that's Idle. In the file system dock on the left, find the Run, Idle and Hurt images in the Res Assets Player folder. Just do it this way then. There we go. That makes life easier. So there's that one. No, I just want that one. That one. And that one. So we want idle next. Can I do all of them at once? I can. Excellent. Idle. And then run. Six. Excellent. Each new animation has a default speed setting of 5 frames per second. This is a little too slow. Select each of the animations and set speed to 8. Ah, there. 8. 8. There we go. To see the animations in action, click the play button. Ah, this one. No, I need the... There, that's better. Alright, I like that. You can also choose an animation to play by default. Select the idle animation and click the autoplay on load button. Autoplay on load. There. Later, you'll write code to select between these animations, depending on what the player is doing. However, you first need to finish setting up the player's nodes. The player image is a bit small, so set the scale properly on animated sprites to 2:2. Scale. Ah, there we go. 2 by 2. Nice. You can find this property under the transform section in the inspector window. We just found it, so that's fine. Collision shape. When using 2D area 2D, apologies, or one of the other collision objects, you need to tell Godot what the shape of the object is. Its collision shape defines the region it occupies and is used to detect overlaps and or collisions. So you see this quite a lot in some slightly more scuffed games where the hitboxes are a bit out of line. It's because they've not properly aligned them properly. You know what I mean. I phrased that badly. Shapes are defined by the various Shape2D types and include rectangles, circles, and polygons. In game development, this is sometimes referred to as a hitbox, as I just said. For convenience, when you need to add a shape to an area or physics body, you can add collision shape2D as a child. Then you can select the type of shape you want and edit its size in the editor. Add collision shape2D as a child of the player node. So we want to go up a level, child node, collision shape2D. Actually, that's 3D. Don't need you. See. Collision shape 2D, that's what I want. Create. Then you can select the type of shape you want and edit its size in the editor. In the inspector window, find the shape property and click empty to select new rectangle shape 2D. There we go. Rectangle shape 2D. Drag the orange handles to adjust the shape size to cover the sprite. Okay. Hint, if you hold the Alt key while dragging a handle, the shape will size symmetrically. Sprite itself isn't symmetric, so we do that. That should be pretty precise, but we'll continue. You may have noticed that the collision shape is not centered on the sprite. That's because the sprite images themselves are not centered vertically. You can fix this by adding a small offset to animated sprite 2D. Select the node and look for the offset property in the inspector window. Set it to 0-5. So get there. Offset. Here we go. 0-5. Oops. So we need to. Ah, no. Remove that. There, better, good. When you finish, your player scene should look like this. So we're following it correctly so far, good. Scripting the player. Now you're ready to add some code to the player. Attaching a script to a node allows you to add additional functionality that isn't provided by the node itself. Click the player node and click the new script button. So that one, that one. In the attach node script window, you can leave the default settings as they are. If you've remembered to save the scene, the script will be automatically named to match the scene's name. Yeah. Click create and you'll be taken to the script window. Boop. Yay! We're off to the races, I should say. Click create and you'll be taken to the script window. Your script will contain some default comments and hints. Good. Makes life easier. The first line of every script describes what type of node it is attached to. Just after that, you can start defining your variables. So, extend it here. And then we need to do... Well, actually, I'm just going to grab a quick drink because I'm very thirsty. All this talking. Just send a quick message as well. Don't tell me I've been doing this entire... Oh, I have, god damn it. For first 50 minutes I've been talking to myself with a dead mic. God damn it. Alright, never mind. It happens. It happens. I'll be right back. Gaze at this code and wonder. Or something. I don't know. Right then. So, hopefully we can go the rest of the stream without any more scuff, but I am not hopeful. Oh, god damn it. Never mind. Never mind. Hi. Hi, dear. Now then. Now then, now then, now then. Oh, that's cut off some of the window. I don't want that. Let's resize that. One moment, just attempting to resize things a little bit so you can see everything properly. What's standard resolution? 1680 by 10 something. That's better. Now you can see what's actually going on. The scarf. Where were we? Yes, we were writing in our inputs. I did all that rabbiting and no one could hear me. Never mind. At least it's a nice musical thing. The VOD will be interesting at least. Right. So, after that, you'll have a velocity vector indicating which direction to move in, so the next step will be to actually update the player's position using that velocity. Click Run Current Scene F6 at the top right and check that you can move the player around using all 4 arrow keys. That is... there. I can't even see the character sprite. Ah. Hey! It's working! Oh, amazing. You may notice that the player continues running off the side of the screen. You can use the clamp function to limit the player's position to minimum and maximum values, preventing them from leaving the screen. Add these 2 lines next, immediately after the previous line. So just down here. So position.x equals clamp, not clamp, clamp position.x 0 screen, there we go, screen size dot x position dot y equals clamp. Yeah, I can spell. Good. Position dot y 0 screen size dot y. The process function. Well, actually, let's give this a test. So if we F6. Yep, he's refined to the screen. Amazing. The process function includes a parameter called delta that is then multiplied by velocity. What is delta? The game engine attempts to run a constant 60 frames per second. However, this can change due to computer slowdowns, either in Godot or from other programs running on a computer at the same time. If the frame rate is not consistent, then it will affect the movement of objects in your game. For example, consider an object that you want to move at 10 pixels every frame. If everything runs smoothly, this will mean that the object moves 600 pixels in 1 second. However, if some of those frames take a bit longer, then there may have been only 50 frames in that second, so the object only moved 500 pixels. Godot, like many game engines and frameworks, solves this by passing you a value called delta, which is the time elapsed since the previous frame. Most of the time this will be very close to 0.016 seconds, around 16 milliseconds. If you then take your desired speed of 600 pixels per second and multiply it by delta, you'll get a movement of exactly 10 pixels. If, however, delta is increased to 0.3 seconds, then the object would move 18 pixels. Overall, the movement speed remains constant and independent of the frame rate. As a side benefit, you can express your movement in units of pixels per second rather than pixels per frame, which is easier to visualize. You're getting an audiobook and seeing coding going at the same time. Aren't you lucky devils? And all for free too. Now that the player can move, you need to change which animated sprite 2D is playing based on whether the player moves or stands still. The art for the run animation faces to the right, which means it needs to be flipped horizontally using the flip H property, which you can see in the inspector window. Go ahead and try toggling it. So we need to select our animated sprite. And flip H. Excellent. Back to our script. Add this code to your process function after the movement code, so just down here. Yes. Do a space. And it says standard if function here, so if velocity dot length open close brackets greater than 0, indent that, at animated sprite. Oh, whoops. That's better. Live debugging, I like that. At animated sprite 2D dot animation equals run. Else at animated sprite 2D dot animation equals. Hey Trojan. Equals idle. Oops, that's fine. If velocity dot x oops 0 oh, that's a $sign, not an @ sign. No wonder it wasn't showing up. So I'm following on a tutorial in a book, so you're going to hear me reading. So you're basically getting an audiobook experience and a programming experience all in one. So we're learning twice as hard today. At least that's the hope. It might be. This is all completely new for me. Well, new. I've not done any programming in 20 odd years, so unexpected indented block. No, that's just proper script layout. Let's see. What was I doing? Dollar. That's the one. Dot animation equals. No, that's not right. I'm jumping ahead. Dot flip underscore h equals velocity dot x less than 0. Note that this jumping ahead here. When using the dollar notation, the node name is relative to the node running the script. For example, $node1/node2 would refer to a node, node2, that is a child of node 1, which is itself a child of the node that runs the script. Godot's autocomplete will suggest node names as you type. Note that if the name contains spaces, you must put quote marks around it. For example, $, quotation mark, my space node, quote. Note that this code takes a little shortcut. Flip h is a Boolean property, which means it can be true or false. A Boolean value is also the result of a comparison, such as less than. Because of this, you can directly set the property equal to the result of the comparison. Play the scene again and check that the animations are correct in each case. So we F6 this. Yay! Oh, this makes me inordinately happy. Just to be already making some kind of progress. Ah. And he's even doing the idle. Oh, very happy. Okay. Starting and ending the player's movement. The main scene will need to inform the player when the game has started and ended. To do that, add a start function to the player, which will set the player's starting position and animation. So new function, so let's do that down here. Do a new line. I'll tell you what, we'll quote this. One little bit of a how can I word this? A little bit of good practice that I learned from way back in my university days. Always make sure you're adding comments to each chunk of script so that if someone has to look at your code later, or if you're looking at your code days, weeks, months later, you can see exactly what's going on where, rather than just trying to wing it. So in fact, what I will do is I will add a little quotation here. Nice. There we go. Lovely. Now we need to type our function. So PNG start set underscore process true. Position equals screen size, whoops, divided by 2, dollar, animated sprite 2D, that's the one, dot animation equals idle. Also add a die function to be called when the player hits an obstacle or runs out of time. Ooh. New function. Go back. Animation. Still can't spell. Come on, man. Funk. Oops, no, that's die. Bit grim, but there we are. $. Animated sprite 2D. Dot animation equals hurt. Set underscore process. Is there a space? No, there isn't. False. Noise. Using setProcess false tells Godot to stop calling the process function every frame. Since the movement code is in that function, you'll no longer be able to move when the game is over. Makes sense. Preparing for collisions. The player should detect when it hits a coin or an obstacle, but you haven't made those objects yet. That's okay because you can use Godot's signal functionality to make it work. Signals are a way for nodes to send out messages that other nodes can detect and react to. Many nodes have built-in signals to alert you when events occur, such as a body colliding or a button being pressed. You can also define custom signals for your own purposes. Signals are used by connecting them to the nodes that you want to listen for them. This connection can be made in the inspect window or in code. Later in the project, you'll learn how to connect signals in both ways. Add the following lines to the top of the script after it extends area 2. So we need to go right back up here. That's not how you spell collisions. There we are. Good. So, signal pickup, signal hurt. These lines declare custom signals that your player will emit when they touch a coin or obstacle. The touches will be detected by Area 2D itself. Select the player node and click the Node tab next to the Inspector tab to see a list of signals the player can emit. Select player. Ah, here we go. Handy. Come on, hands, work properly. There we go. Note your custom signals there as well. Since the other objects will also be Area 2D nodes, you'll want to use the area_entered signal. Select it and click Connect. Let's see, area entered, this one here, Connect. In the window that pops up, click Connect again. Okay, so it's connecting to the player, that's good. You don't need to change any of those settings. Godot will automatically create a new function called onAreaEntered in your script. As we do. When connecting a signal, instead of having Godot create the function for you, you can also give the name of an existing function that you want to use instead. Toggle the make function switch off if you don't want Godot to create the function for you. Add the following code to this note. New function. So, function onArea, entered area, if, skip, no, Get that down there. That's better. If area dot is in group coins area dot pick up dot emit. Oh, there we go. If no, that is right. Area dot is in group obstacles. Yeah, that is right. Hertz dot emit. Doot doot. And then call the die function from earlier. So how am I going to word this properly? Yes, I'm just on a GeForce RTX 2060. I am poor. Collision event. Yeah, that makes sense. That makes sense to me. Whenever another area object overlaps with the player, this function will be called, and that overlapping area will be passed in with the area parameter. The coin object will have a pickup function that defines what that coin does when picked up, playing an animation or a sound, for example. When you create the coins and obstacles, you assign them to the appropriate group so that they can be detected correctly. Then there's a summary of the script, which we have... Yes, we've written. Very nice. You've completed setting up the player object, and you've tested that the movement and animations work correctly. Before you move on to the next step, review the player scene setup and the script, and make sure you understand what you've done and why. In the next section, you'll make some objects for the player to collect. So let me just save. Where's my save? Save all scenes. Boop. Done. I'll tell you what, just because it fills me with a distinct level of joy. I'm not sure this the screen position thing is quite correct, but we'll... Let me go back. No, it's right here. So let me set the player for a new game. Yeah, no, I've done it right. Just screen size divided by 2. Yeah. Huh. Alright, we'll come back to it. Part 2, the coin scene. In this part, you'll make coins for the player to connect, and strange time for Birdie's theme to kick in, but never mind. You'll make coins for the player to collect. This will be a separate scene describing all the properties and behaviour of a single coin. Once saved, the main scene will load this one and create multiple instances, that is, copies, of it. So this is our little collectibles that we're going to be working on now. So, jolly good. So we want to create a new scene and call it coin. Boop. was it we had selected before? Area 2D, that was it. Call that coin. COLL. Shape 2D. Perfect. Good. Share to save the scene once you've added the nodes. So, there we go. Where we to go here? So assets, coin. Have I selected the... No. No, Area 2D, that was the right one. Oh. Silly bugger. There, better. Is what did I do? Here. No, it was there, wasn't it? Sprite frames. So I want to go. New sprite frames, animation, default. Scale, let's do 0.4. It's 0.4, that's fine. Animation speed. Is it this one? As well. There we are. Whew. Makes it a bit difficult sometimes. That's that there. And preview button. Cool, happy with that. In collision, shape 2D. So here we go. Shape circle. And resize it to cover the coin image. Just like that. Oh, whatever, it doesn't matter. Let's see. Groups provide a tagging system for nodes, allowing you to identify similar nodes. A node can belong to any number of groups. In order for the player script to correctly detect a coin, you need to ensure that all coins will be in a group called coins. Select the coin node. That one. Wait, no. Click on the node tab. And choose groups. Okay. Type coins in the box and click add. There we go. Your next step is to add a script to the coin node. Select the node and click the new script button. Ah, there. Yeah, that's all fine. Cool. Select the node and click the new script button, just like you did with the player node. If you uncheck the template option, you'll get an empty script without any comments or suggestions. The code for the coin is much shorter than the code for the player. So extends area 2D, var screen size, vector 2.0. Vector 2.0. Up. Q underscore free. Don't think I need all this. Scrap that. Recall that the pickup function is called by the player script. It defines that the coin will do what the coin will do when collected. Q3 is Godot's method for removing nodes. It simply removes the node from the tree and deletes it from memory along with all its children. Later you'll add visual and audio effects here, but for now just having the coin disappear is good enough. Removing nodes. Q3 doesn't delete the object immediately, but rather adds it to a queue to be deleted at the end of the current frame. This is safer than immediately deleting the node because other code running in the game may still need the code to exist. By waiting till the end of the frame, Godot can be sure that all code that can access the node has completed and the node can be removed safely. You've now completed the second of the 2 objects needed for this game. The coin object is ready to be placed randomly on the screen, and it can detect when it's touched by the player, so it can be collected. The remaining piece of the puzzle is how to put it all together. In the next section, you'll create a third scene to randomly create coins and allow the player to interact with them. What's exciting? Save all scenes. The main scene is what ties all the pieces of the game together. It will manage the player, the coins, the clock, and all the other pieces of the game. Create a new scene and add a node called main. So new scene. Wait, no, hang on. I just spotted something critically wrong. Make scene like root. Oh, curse! That's not gone right. Sugar. I have to do that again. Oh, well, it's good practice. Good practice. Good practice. So we want animation. Sprite. There we go. Grab those, pop those down there. Let's do 12 frames. Excellent. That saved some time. Jesus. Right, so we need to resize this. 0.4 by 0.4. Good. Save that. Save all scenes. Right. Fully sorted now. Why is this not... I don't want a node 2D, I want an area 2D. Better. Jesus. We're going to be a bloody dab hand at this by the end of it. Oh, Jesus Christ. 12. Transform 1.4. 1.4. Good. Save all scenes. Okay. Actually, must be provided. Provide a shape resource. This is... Oh, that's it. Shape. Circle. Slightly off center. Damn it. Damn it. That'll do. Select the coin node. So we're going to do this again very quickly. Node groups. Coins. Add. Okay, good. Simple Cs. Alright, good. Create a new scene and add a node called main. So I'm just assuming just another area 2D. No, don't do it there. God damn it. God, it's bloody fussy, isn't it? Jesus Christ. Okay. Is it just... Okay, fair enough. Fine. Whatever. I'm not sure if that's bullshit. Node setup, right. Create a new scene and add a node called main. Done. The simplest type of node is node. It doesn't do much at all on its own, but you'll use it as the parent for all the game objects and add a script that will give it the functionality you need. Save the scene. Done. Add the player as a child of main by clicking the Instantiate Child Scene button. Jesus Christ. Choosing your saved player. Okay. Never heard the term the word instantiate before, but there we are. I learn something new every day. Add the following nodes as a child of main. Texture. Call that background. Timer, handy. Make sure the background is the first child node by dragging it above the player in the node list. Okay, so it's got to go there. Fine. Nodes are drawn in the order shown in the tree, so if background is first, then it ensures it's drawn behind the player. Add an image to the background node by dragging the grass.png image from the assets folder into the texture property. No, don't. That one, thank you. Jesus. What, so I can quite literally just drag and drop, is it? Assets. Grass. Did that do anything? Open. There we go. Excellent. Change stretch mode to tile. There we go. And set the size to full rect by clicking the layout button at the top of the editor window. Okay. Where's that then? Layout. Inherited. Oh, there. Full rect. Cool. Okay. Hi. Right, so hopefully I've done that right. Add the following variables. So export var coin underscore scene packed scene Oops. Equals 30. Var equals 1. Score equals 0. Var time left equals 0. Var screen size equals vector2 dot 0. Var playing equals false. Okay. The coin scene and playtime properties now appear in the inspector window when you select the main node. Huh. Awesome. Did that straight away. Drag coin.tscn from the Files System panel and drop it into the coin scene property. Alright, we'll have to do it this way. Where's my coin? There we are. Alright then. That was weird. Initializing. To start things off, add the _ready function. So we can scrap this and put it here, I believe. Ready. Screen size equals get _view. Oh, there we go. Viewport dot get visible. Yeah, there we go. Dot size dollar player screen size equals screen size dollar player dot hide. Okay. Might be able to get this done fairly quickly. Go.dot automatically calls ready on every node when it's added. This is a good place to put code that you want to happen at the beginning of a node's lifetime. Note that you're referring to the player node by name using the $ syntax, allowing you to find the size of the game screen and set the player's screen size variable .hide. Makes the node invisible, so you won't see the player before the game starts. Makes sense. The new game function will initialize everything for a new game. So oh, I need to add this now. I was a bit confused by what it was trying to tell me in this book. I was like, oh, it's actually telling me to write this code. Let's see. Func new _game playing equals true. Level equals 1. Score equals 0. Time _left equals playtime. Dollar player. Nope. Player. Dot start. Dollar player dot show. Dollar game timer dot start. Spawn underscore coins. Do. In addition to setting the variables to their starting values, this function calls the player's start function that you wrote earlier. We did. The starting game timer will start counting down the remaining time in the game. You also need a function that will create a number of coins based on the current level. Ooh. Tank spawn underscore coins. For I in level +4 var c equals coin coin scene dot instantiate. Still don't know that word. I'll have to look it up later. Add there we go. Add child c dot screen size equals screen size c dot position equals vector 2 randy underscore range. I don't know what that means, but we'll go with it. Zero screen size dot x randy range 0 screen size dot y, one bracket. Actually, two brackets. Yeah, I'm trying to add one, but it's derping out at me. Indented too far. There, fixed. So what? Throat's getting a little ragged. Let's save that for a minute. So, reflecting so far. Actually, I need a bookmarker as well. We've created the player character, created the coins, creating the background. We've put some basic code in there. And soon we will be putting it all together into what should be a fully functional game. But before that, we'll have to add in remaining coins, create a user interface, and then all the bits and pieces around it. Score, time display, and updating the script. But we should, theoretically, be nearly there. Actually, no, I'm looking ahead, and we're not there at all. Getting far too overzealous. But yes, as I said at the start, when I before I realised that my mic had been muted this entire time, I will tweet out a link to Godot, the engine I'm using here, after stream, and I'll also link to their social media should you wish to check out the company themselves. But I think, because my throat is getting a little sore, I think that might be I might have to call it a little bit ahead of time, but we will continue this next week because we don't want to lose momentum unless people absolutely demand another stream during the week. And who am I to argue? But before that, other than that, let me just switch to our just chatting tab while we look to find someone to raid. So is that all saved? Give it another quick save just to be safe. Now then, let's see who is about. There's Lulu, Clauvio is about, and there's Kaneko Lumi and a whole bunch of other people like Saraway, Vey, and actually a lot of people I don't know. So let's go for Clauvio. I think that might be nice. But yes, thank you all very much for joining me today. It's very exciting, and I'm immensely happy with the progress that we've made. And I will see you same time next week, 3 o'clock UK time.
You were pregnant and then you went to the doctor and then the doctor did an ultrasound, but then it turns out the baby was actually spiders. You just had like hundreds of spiders in your stomach and they're ready to come out. Just something horrific. Hello, King Crix. Hi. Welcome in. Hello, Pascals. I did change my hair. I'm Ashley today. Please refer to me as Ashley. I wonder if you'd get really smart. I don't know if you would get smart. I think if you lose like a large part of your brain, you are gonna drop some IQ points, but it depends on like how much is missing and like since when. Amsterdam, thank you for the 2 months. Hello. I know, Lex! King Crix. I didn't know I was subbing to Ashley, but okay, I guess. Yeah, today your subs are gonna go to Ashley Mouse. Just Ashley. I'm just Ashley today. I'm nobody important. I'm just a regular girl, you know? I'm Ashley. Oh my god, hello! Akashi! Good to see you again. Yeah, I'm just a girl. I'm a real human being. Okay, I have to rotate the right stick. We're learning how to play the game. Clavio is resting right now. I turn into Clavio when the full cheese comes out. You guys know this? I told you I used to be human before. I used to be Ashley. And sometimes I become Ashley again. Well, it's a dash shield, you'll run quick. What? I'm not internalizing this tutorial because I'm trying to explain all this stuff going on. I'll do my best. Yeah, it does depend on what part of the brain as well. Like, Grimmy's missing part of her brain, but it's like a small part, and she's like fine, because the brain adapts very well.